Here we're asked to give the amplitude, period, and phase shift of a periodic function y equals 2 sine of 4 pi x minus pi over 6. We're also asked to graph the function. So periodic functions will come in the form of y equals a times a sine or cosine of an omega times a variable minus what's called a phase difference. So the easiest here to identify would be the amplitude. The amplitude is 2. The omega in this particular function, that's the angular frequency it's called, is 4 pi. It's going to be the constants that are attached to the variable. And we see that there's a phase difference of pi over 6. So we know that the amplitude is going to be 2. In order to find the period, we can use a formula that relates period and angular frequency. The formula is omega equals 2 pi over t, where t is called the period. If we rearrange this formula, we would get that t equals 2 pi over omega. So if we just plug in for omega, we'll get that the period here is 1/2. Next, it's important to note that in many math textbooks, the phase shift refers to a horizontal shift of the function. And that is different from what is sometimes referred to as a phase difference. Very similar terms, but different meaning. Phase difference has the Greek letter phi, whereas I often use just h to represent the horizontal shift. Now, the relationship between horizontal shift and phi would come from factoring out the omega. We could factor this expression to transform it a little bit and see what the horizontal shift really is. So what I'll do is I'm going to multiply this phi by omega over omega. Omega over omega is of course 1, but the reason I'm doing this is so that I can factor omega out and leave behind x minus phi over omega. The purpose of this is in order to see what the horizontal shift really is. So for a horizontal shift, whenever you have a function f of x minus h, that is a horizontal shift of h units. And it's going to be h units to the right. Here's a simple example of it. Take the function f of x equals x squared, and now I'll modify the function. I'll modify the function by subtracting directly to the x. What this does is it shifts it to the right 2 units. You could also write this as x minus 2 squared. So if we apply a subtraction directly to the x, what it does is it shifts the function to the right that many units. So the reason why I factored out the omega is so that I can see exactly what is being subtracted directly from x. Because this phi over omega is the horizontal shift h. So we have that h equals phi over omega. So when they ask for the phase shift, that is going to be h. It's going to be phi over omega, which for this particular problem is pi over 6 divided by 4 pi. The pi's will cancel, and this simplifies to 1 over 24. All right, so now we're asked to sketch the function. Sine normally would cross through the origin and normally it would complete its cycle after 2 pi radians. So it would start at 0 and complete a full cycle at 2 pi. Our period here, though, is 1/2. So what that means is it's not going to complete its cycle at 2 pi. It's going to be compressed. It's going to be compressed in such a way that it completes a cycle much earlier. At an x of 1/2 is when it completes the cycle. We get to create our own axes here, though, and our own scale. So what I might do to just make it simpler is just label this point where it completes the cycle as 1/2. That would be fine. We need the amplitude to be 2, so we need the height of the peak here to occur at a y value of 2. And then the trough would occur at -2. However, this would be an example of y equals 2 sine of 4 pi x with no phase shift and no phase difference. So the phase shift is going to be a horizontal shift. And we determined that it needs to be shifted by a value of 1 over 24. And it's going to be shifted to the right. So 1 over 24 is a pretty small shift. So what I might do is just maintain the same scale and height and dimensions of the curve. But let's shift it just a little bit to the right. And so where should it intersect the x-axis? At an x of 1 over 24. And the function will touch the axis there at 1/2 plus 1 over 24. And that's the function. We can confirm this by plotting it in Desmos. So the Desmos graph looks very much like my graph.